Hello everyone, my name is Anmol Nijaman and today I will be explaining the pumping lemma for the regular languages. So, pumping lemma is used to prove that a language is not regular. It cannot be used to prove that a language is regular. So, what do we mean by a regular or a non-regular language? Any language that can be determined or expressed by a finite state machine is called a regular language, whereas any language that cannot be expressed or determined by a finite state machine is called a non-regular language. So, non-regular language cannot be expressed or determined by a finite state machine. To prove any language is not regular, we prove it by contradiction. So the steps outlined for proving that a language is not regular are as follows. The first step is we assume that a language A is regular. Then we determine the pumping length for the regular language P. Now we find a string S in the regular language A such that the length of the string is greater than or equals to the pumping length P. Here A is used for defining the regular language, whereas mod S is used for defining the length of the string. Now that we have a string S such that its length is greater than the pumping length P, we divide the S such that S can be expressed in S equals to X, Y and Z, wherein it has to follow the following set of three conditions, such that if x, y to the power I and z for every I greater than or equals to 0, this expression should belong to the regular language A, the length of the string y should always be greater than 0, and the length of the string xy should always be less than the pumping length P. These three conditions need to be satisfied. Then we consider all the ways in which the string S can be divided into X, Y and Z, and if we are able to find at least one string that can be made from pumping this Y multiple number of times such that this expression X, Y and Z, that is the string S, does not belong to the regular language A, then we say that the language A is non-regular.